So, Leo, what I wanted to ask you about base case and general case. Again, no need to worry about anything. I'm here just to know what to explain or what to skip. So, do you mind if you would like to share with me? So that is, are you able to know what this function first is doing? So let's go through the discussion first, and after this we talk about base case and general case.
Yes, so what this function does is essentially it adds n and every number lower than that together and returns the sum of it.
Excellent answer. Okay. And why we don't use a for loop to do that? Can we use a for loop to do that?
No.
Sure.
Actually, yeah, you could.
So, okay, can I ask you for another homework, please? Can you do summing of numbers? So if I give you 5 here, I want you to do a function in Java that can actually count from 5 until you reach, for example, 0 or even 1, because 0 doesn't make sense. So from 5 to 1, I would like you to add them in a Java function using a for loop. Can you do that, please? Not now.
Yep.
Okay, good. So because actually the recursion is actually taught in comparison to for loop, but I want to focus on the exam questions at the moment. So, but I want you to get that information. Can you do that for me tomorrow and share it with me?
Yes.
Okay, good. So, okay. Are you still able to guess the base case and the general case? So, okay. I want you forget about that. Forget about my question.
Wait. The general case would be the return n plus sum to n and minus 1.
Mm-hmm. And the base case would be?
Return 1.
Okay. And why is the base case important?
Because that's what like ends the recursion.
Perfect answer. Okay. So do you see the difference between this portion and that portion? So this is a pseudocode and that is just like Java. Is a big difference?
Yes.
In the functionality, I mean. So do you see any big difference? If you see that code, are you able to implement that code?
Yes.
Okay, good. So why we need to use a recursion and what is the disadvantage? Because that is actually an exam question also. What is the disadvantage of a recursion? And what is the advantage?
So a disadvantage of recursion would be that the incremental and repeating nature of it means that it can use up a lot of processing power and memory.
Mm-hmm. Okay, it doesn't use more processing power, but it uses a lot of memory. Yes. Okay, and it is slower, right?
Yes.
Okay, perfect. And what is the advantage?
Well, an advantage would be in terms of like actually like writing it in terms of like the code itself, it can be like shorter, which can be more efficient in that regard.
So the only advantage is that you write only a few lines. So if you design your base case correctly, you will end up writing only a few lines to achieve your function. Okay, and it's easier to read, but actually it is very hard to trace. So if you would like to actually troubleshoot or debug a code in in a recursion function is actually quite hard. And the only way to do that, of course, if you use that using pseudocode, it's almost impossible because pseudocode is not executed. It can be only written on a paper, and there is no popular or even standard debugger for that that you can execute the pseudocode. So so you see here what he's doing. This is a way to debug, but of course that is more. It makes more sense to use it in a code like Java, because only then your print statement will make sense. So can you see the importance, please, of these print statements that I'm adding? Do you know why we added that print statements?
To trace, to like see what the algorithm is doing.
Okay, so you will see multiple of that. How many times you will see this returning one?
Just once.
Okay. And in this case, yes, it's true. And how many times this will occur? If we are talking about 5, for example, if we passing n equal 5.
5 times.
Okay, 5 times or less? Could be. Yeah. Okay. Yes. 5 times or less. Yes. Now, if I have a function like that, are you able to tell me what this function is doing and what could be the output? So here, this is a recursion. I am doing something. I am passing here x and y with these values. So I would like to know what could be the output. Do you know how to make a trace table?
You'd have to. Oh yeah. Trace table. Yeah, I do.
Okay. So okay. Do you know how to write down that? I mean the tracing. So even if you don't do a trace table in the exam, but there must be a way for you to be able to know what this function returns, because that is also. I mean, yes, this is a slightly different exercise and slightly difficult than the one that comes in the exam, but exams also will give you. So he will say something like that, and we will see just now in 2023, we have an exam question. He give you a function, a recursive function, and then he give you 5 and tell me what could be the output if I pass 5. So there must be a way for you to be able to actually write down and get the answer of such a thing. So I would say this do something. I will refer to do O, and I will pass, when I pass 5 and 2, then what this 5 and 2 will return to me here.
Uh, 4 and 7.
And when we have 4 and 7, sorry. Okay, what else?
And then 3 and 11.
Mm-hmm.
And then 2 and 14. Then 1 and 16.
Okay, that's it. Anything else?
No, and then after that, since x is 1, it returns 16.
So this will be printed out or returned, right?
Yes.
Okay. Good. And I think so that is a trace table. It helps that you actually so here he is checking true or false for the base case, and here he is writing down like what I wrote just now. So if you want to fill in what we did just now, so he say do something, and then 3, you said 3 and 11, right?
Yes.
And then he here do, and then 2 and 14.
Yes,
and then 1 and
and then
16, right?
116. Yes.
And then this become true, right?
Yes.
Okay. So here you will write the number of calls. I think when you see a recursive function that is difficult, it might be very helpful to actually write that. I have seen in some exams, standard exams, but not in your specialization, that actually they come up with this kind of a trace table and ask the students to fill it in. But I don't think in your case. Your case, you just only need the output, how it looks like, and how you work it out. They need to see how you write down that. So they don't judge you only by the result. I think they need to see how you reach that result. Not necessarily a trace table. So you find a way, or we will see a way that we do that. So can you see that function and tell me what can this do?
So in this case, it essentially keeps adding one to the number, and sorry.
So
Oh,
do you remember
it
what
adds.
this do first? What this div do?
It divides it.
Only? So if I say um, 10 div 3 equal?
Well, it. How do I say it? Like it. Well, div specifically only returns like integer values.
Okay, so instead of 3.3, it will
You
only.
could just 3. Yeah.
Okay, perfect. Okay, good.
Yes. So it's n divided by 2, but just the integer value of it with 1 added, and then it repeatedly does that until it eventually reaches 1, and then it returns 0.
Okay, so if we start with 100 and then we say div 2, then the second n will be, the second
50?
call for n will be
Okay. Second call for n would be 51.
51. You sure?
Yeah, because there's still.
No, this is
Oh,
not part of
sorry.
it. 50.
Oh, yeah, sorry. The second call would be 50. Yeah.
And then the second call, the third call. So that's 1, 2, 3, 50 divided by 2.
25.
Divided by more 2.
12.
Here.
6.
Mm-hmm.
And then 3. I mean, yeah, 3 and then 1. And then it would return 0.
Excellent. So it will return 0 here. Good. And then what could be the result here then? So for every time we do this, so when we are here, for every time we call the function again, we add 1. How many times we added 1? Here, do we add 1 here?
No, because that's the last time.
Okay, so we added 1 here, 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 here.
Yes, 5 times, yes.
So it is 5 or 6?
5, because 100 would just be like the original n value.
Yes, but when it comes here and we start calling for 50, we also added 1.
Oh yeah, then yeah, it would add 1 as well, so 6 times.
Okay, perfect. But Leo, we need more exercises here, I believe. Actually, the result is 6, like I told you. Okay, so Leo,
Yes.
are you still following up? We need to do more exercises here. So I would like you, Leo. I'm sorry, I have to push you a little bit because I see we only have 1 month towards the exam, right?
Yes.
And we also have limited time in our class. So I only can pinpoint to you where you need to push yourself more. I will try to fill in the gaps as much as I can, but I'm not saying that you are in a bad condition. No, you are smart, and definitely what I am pointing to you, you can only grab. I mean, in total, what I pointed to you today, you can only grab less than 1 hour, but you need to grab it because that will be a question. So I'm sorry, this you need to actually do in Java. In paper 1, it is commonly said, although sometimes they write to you that you need to write in pseudocode. If you stuck in pseudocode, it's allowed to write in Java. It's allowed to write your answers in Java, actually, and they accept that. Okay, so some people not. So this exam, people can write in pseudocode, you write in Java, and you write. Some people can write in Python even. Okay, because yes, this IP is actually taken in different languages. So I would say have a look at this exercise, Fibonacci, and see how you can produce such numbers by creating a recursion function in Java. Okay, but not now, as a homework. Leo,
Yes, yes.
am I pushing you too hard?
I know, that's fine.
Really?
Yeah.
I mean, I think yes, I don't do that with other students, to be frank. But again, Leo, your level and your smartness is higher than others. I can see that you are from the top students I ever taught. So I believe, yes, of course, sometimes I can guess from your answers that you are guessing it, and you are not 100% knowing it from before. But at least you are able to come up with some answers. I like that in you, and which also makes sure that this will give you the ability to answer even if you are not very sure about what you're writing in the exam. But of course, we don't want to reach that level. You are studying and preparing to be able to achieve. So no point to reach that level. But what I'm saying that you are able to, yes, I'm pushing you harder than others, but I see a space for that. I see your ability can really tackle for that. So don't get it so bad. If I reach a level that makes you unhappy, uncomfortable, tell me. I will stop pushing you. But it's for your own benefit.
Yeah.
Okay. But at the end, if I make you uncomfortable and not happy with the class, we will reach nowhere. Okay. So you have to tell me it's too much. Okay. Fine.
Yep.
Okay. Good. I will not show you the answer here, but so that is actually an exam question, Leo. Can you see that?
Yes.
Okay. Are you able to tell here REC 5? How can we calculate an answer for that? So that is a pseudocode. And he mentioned here 2 disadvantages that you have to mention for a recursive method. We already talked about it, so we don't need to discuss here this point, but we need to see this rec 5. What could be the result?
Well, first of all, 5 is bigger than 2, so you'd be returning rec 3 plus rec 4, of which both of those are also bigger than 2. So for each of those, so for rec 3, you'd be returning rec 1 and rec 2, and then for rec 4, you'd be returning rec 2 and rec 3.
Okay.
And then rec 1 is smaller than 2, so that just returns 1. Then rec 2 returns rec 0 and rec 1, both of which were smaller than 1, so both of those also return 1.
So rec 2 will be returning
2.
also rec 0.
Yeah.
Am I right? Correct?
Yes.
Plus and rec 3.
Rec 3, well, we've gone over it before there, so it's rec 1 and rec 2, of where rec 1 returns 1, and then rec 2 ends up returning 2, because it's rec 1 and rec 0, both of which return 1.
Mm-hmm. Okay, so this rec 0 and 1 will return what?
2.
2, okay. Plus and 0 and 1, another 2.
Yes.
And this 2 will return what?
2.
Okay. And this one?
1.
So is that correct?
Yeah, so it would return, yes, 8.
Sure?
From what I can tell, yes.
Okay. Let me see the answer. Let me see the answer. Yes. So actually what you mentioned is actually correct. And so the method that we used, I think this is matches even the original answer that is giving. So I think if you follow this way, it can it doesn't make you need to write the trace table. Okay, is it fine like that? Is it clear?
Yes.
Leo? Okay, good.
Yes.
So that is the official answer, but let me go to that question, Leo. So Leo, that is also a recursive question. Can you have a look at this question, please? This is in 2022. So he's giving you 1D array, and he give you that recursive function, and he want to know what is the output if he call mystery with the names, and names is the array. This is the names array, and this is 3. So he pass n here equals 3. So what could be the result? Have a look, Leo. This is a non-traditional
Did the
way.
audio cut out, or did you just stop talking?
No, it's cut off. I'm not sure why. Okay, so what is the last thing that you hear from me? Huh? Tell me, Leo.
Oh,
Can you
well,
hear me?
yeah, now I can hear it. It was only for a few seconds.
Okay, so Leo, what I was telling you that we would like to know the output if we pass to this function the array and n equals 3. Okay, so if, of course, logically, this function is doing some operation on the array. Okay, so we would like to know what is output in sequence in this function. Actually, quite tricky, not straightforward. But you are a smart guy, Leo.
Well, okay, yeah. So to start off, 3 is bigger than 0, so it would become mystery names 2. And then once again, n is bigger than 0, so it becomes names 1. And then it would become names 0. And then after that, and at that point, since like 3 minus 3 is, wait, is that? So that's like asking about the array member, so. Yeah, so, oh yeah, so it's 0, so it wouldn't be able to go any lower. So at that point, it would output the name at index 0 in the array.
You sure?
Oh wait, sorry.
Okay.
Oh, I
what
see.
is the
Okay, wait,
value
I
of
see. Yeah.
n? So
Oh wait, and it would be 0 here. Yeah, so it would be returning a Kim since that's yeah.
So 3, right?
Yes.
So Kim, right?
Yes.
So we will output here Kim. Okay,
Yes.
good. And then what else? Is it finished? We will not be able to output anything else?
Oh well, the if has ended and it's been outputted, so I don't think anything. So the algorithm would be over at that point, right?
No, because this is a recursion means that okay, yes, you output here Kim, but then you have to rewind again. It means that yes, you reached your maximum, but a recursion means that when you keep calling that, it means that okay. Can you write this function in if we have to write it in Java, this is the only way for you to understand it. So okay, I want to
wait, I think wait. So
Tell
this
me what
just
you
like
think.
it like outputs every name in order of index.
Yes, you are correct. So we only reach, so for here we didn't even reach that portion because we called that mystery again to reach here. So if we reached here, it means that this function will finish and it will return back to the calling function. The calling function have n1, so it will execute end if and then it will output. So what it will output? Two n equal 1 in this case, 3. It means that A2, which is Ili. So it will print Ili because it will come here, right? And then when it go back to the calling function, the n equal 2. So it will come here to the end if, and then it will print this. So it will print what?
After Ellie or so.
Yes, so if A 3 minus 2.
Yeah. That's index position 1, so morality.
Okay, and okay, now I want to understand now. So the one that was called at the start, this one, will print something or no?
The one that was called at the start.
Yes, so because when we called that, it enters here, right?
Yes.
And it keep calling the other recursive calls with 2, 1, and 0, but it never executed that line. I mean, when it was 3, when n was 3.
Yes.
Okay, so when we return back from our calls and we start to, so when we return back from the recursive calls, we will come here and if, and then we will try to execute output. So what will be the output now? Will we output that or something else?
Yeah, I think something else would be outputted.
Okay, so let me understand with you. Now, what is the value of n now here when you first call?
3.
3 minus 3.
0.
So when you output A0, what is that?
Z-sun.
So it will output here, right? I know this is tricky, and to be frank, I know this is very tricky. But that is the level of the questions in the exam. So we somehow need to think how we can train ourselves to that level. I think me and you think that is tricky or not. Let me try to understand what you're feeling. Do you need to practice more or you are fine?
I think I need to practice a little more. Yeah.
Okay.
But I think I can do that in my own time as well.
Perfect. So I can just give you an exercises and then you can do it on your own, right?
Yes.
Perfect. So we can tackle another topic.
Yep.
Okay, good. So do you have anything to tell me? Are we moving slowly? Should we move faster? Or what is the thing that you need to tell me so that we can adjust in the next classes?
I think the pace right now is fine, in my opinion.
Okay. Do you like to listen more to the theory, or we should focus on exam questions and explain the theory when it comes by when we see the exam questions? So is it this way is okay?
I think it would be good to focus more on exam questions.
Okay, good. Okay, see you tomorrow then.
Yep. Thank you.
Okay, thanks. Bye bye.